Hello. I know that some of you may not have a lot of experience with electronics or programming, so I just wanted to go over a few things. You have a prototyping board, or sometimes called a breadboard, and so the thing you need to know about this board, it's nice because you can just plug stuff into it and do prototyping pretty quickly, move things around. But you have these two rails on either end here, and so these lines are all connected. So in other words, if you put in a positive, say if you put in your 3.3 volts here, then you'll have 3.3 volts all along here. And if this is ground, right, they're not connected. This is a separate rail. Again, all the way down this column here, you have the same voltage. And whereas the ones in the middle, they're all connected across this way. So the ones on the ends are connected as you move in this direction, and but inside here, these pins are all connected. They're not connected as you jump across to the other side. So these 5 pins right here, that's labeled number 9. Those would be all connected, but they're not connected to this side over here. And you can put like 2 boards together. You may or may not want to plug your ESP32 into one of these. But your other components, your op-amps and whatnot, and and resistors and diodes, you probably want to plug into a board like this. So, okay. So the other thing I wanted to talk about a little bit was just some of the programming things, because we haven't really talked about this very much in class. So if you just go to File and Examples, in this case, basics. That's where I found this link. So there's lots of example programs. So let's just talk about a few things here. So first of all, the LED built in, that's 13 is usually reserved as an output pin, and most of the Arduino boards have an LED that's a really small little LED in the board that's already connected to that, so that if it's high, that LED is on. You can set up your own, on your breadboard, your own LED with a current limiting resistor. And then under setup here, that you have to use this thing. In other words, we're going to set this pin. This is pin 13 here. As an output pin. So you normally either declare a pin as an input or an output, and then you give it the number of the pin here. And on Canvas, there's a link to the ESP32 board, and it tells you like which pins you can use. Some of them are output only, some of them are input only. Some of them can be used as analog to digital converters, and so we'll talk a little bit more about that later. And so all this program does right here now in this loop section, it does a digital write. So in other words, if you have this pin set up as a digital output, then you can do a digital write, give the pin number, and high is the same as true, is the same as a non-zero number. So low is the same as false or 0. So you can see the delay is 1,000 milliseconds, so basically it turns it on, waits a second, turns it off, waits a second, and so on. So that's a pretty simple program, but again, it gives you the idea of how using this pin mode to declare the pins, and then how you write to the pin. And of course, you would use digital read if you wanted to read a digital pin, input pin. Now the input pins are they're set to really high impedance or high resistance. Just like with a voltmeter, you don't want current going in there, you just want to read the value. Whereas the outputs, you want the impedance or resistance set low because you're trying to provide some current through it. So that does make a difference whether you say it's an input or an output for that reason. So one other thing I'd mention is if you click on Help here and go to Reference, then you can get all kinds of information. If you go to Learning and Tutorials, here's built-in examples, so we can just go down and there's Blink right there. So the if you can go down here. We have an ESP32, so it doesn't look quite the same as this, but you get the idea. You can set up an external LED with the, in this case, they're showing a 220 ohm resistor. You can use something a little higher than that if you want to. And yeah, there's the wiring diagram. And again, it explains about these the different commands here. And then there's a sample program. So, and it gives you other things you can look at. So this is really, really useful. Also, if you go to resources and click on reference, so you can see there's digital read, digital write, analog read, and so on. So you can click on any of these functions here, and so it's pretty easy to use, and there's lots of examples. So let's look at another example. So this is an example of wiring up a potentiometer to control the position of a servo. And to get to this one, I went to, first I went to Tools and then Manage Libraries, and to get the servo class to control the servo, I typed in ESP32 servo, and I've already installed it. So install is grayed out because I've already installed it. And then once you install it, then if you go to File and Examples and go down here, you can see this Esp Servo, and here's some examples. So this is I just selected knob there. So and this gives some useful information about servos, and we'll be talking about pulse width modulation in class. But basically, this uses to control the servo. You basically send it a PWM signal. So you'll see on the ESP32 that some of the pins designated that they can be used for pulse width modulation. So that uses basically you have a high or a low signal. Well, how do you control the speed of a motor if it's just either high or low? Well, what you do is you send it a square wave, and basically the proportion of the total length of the wave, the height of the length of time that it's high compared to the total length of the wave, that's like a percentage. It's called a duty cycle, and that can convey information. And so what this 500 to 2500 is talking about, typical servos, those are actually microseconds, right? So the servo typically is 50 hertz, so it's 20 milliseconds long, and so this would be 500 to 2500 would be a half a millisecond to 2.5 milliseconds. And then the VEX ones, if you're familiar with that, they're usually 1000 to 2000 microseconds, or 1 to 2 milliseconds. So that would be a 5% to a 10% duty cycle out of the 20 milliseconds. So that conveys the information about, if it's 1000, then that means you want to go full speed in one direction. Then like 1500 would be stopped. Or I'm sorry, I'm getting this mixed up with motors. You use the same thing to control motors. But so 1000 would be 0 degrees, and 2000 might be 180 degrees. So that's how you convey information to the servo in terms of what angle to turn to. And so now if we go down here and look at that, you can see here's our servo pin, and here's the potentiometer pin. So the potentiometer, if we hook it up to the ESP32, we want it to put the ground and then the power to 3.3 volts. So it's going to vary between 0 and 3.3 volts as we turn it. And the ADD converter is going to convert that. It's called a 12-bit ADD converter, which means you can see 4096. Well, that's 2 raised to the 12. It's 12-bit. You have 4096 possible values, so it's going to vary from 0 to 4095 actually. Okay, so the first thing we have to do is attach the servo, the ESP32 servo library that if you've used the VEX Cortex before, the servo library servo.h is not quite the same as the ESP32 servo.h. You still use the same command to actually declare the servo itself. But so right here, in other words, we say servo and then call it my servo. So that servo instantiation is still the same as with the Arduino, but the library is actually ESP32 servo.h. So anyways, this creates a servo object called my servo, and when we go down to setup here, first of all, the Arduino servo object runs at 50 Hertz automatically. But with the ESP32 servo, you can actually change the frequency. So that's why this command is here, set period Hertz to 50. So there'll be 50 Hertz. And then we're attaching it, so my servo.attach, attaching it to the servo pin, which we've set up here as 17 or 18. You can read this. You can see there's different pins that you can use for these things. And then 1000 to 2000, so that would vary. That's in a sense, that's going to vary from 0 to 180 degrees, the way that's interpreted. Okay, and then we set up the serial port. And so anyways, now this analog read is going to read the potentiometer, which again, it's going to be at a voltage between 0 and 3.3 volts. But the value that it returns is going to be between, this says between 0 and 1023, but it's actually going to be between 0. That would be for a 10-bit ADD converter, but if we use all 12 bits, it would be between 0 and 4095. Okay, so now we have that value, and we want to print out that value, so we use serial.print. Serial.println moves to the next line. So if you just do serial.print, it prints whatever you've got, but then it just, if you print something else, it would just pick up at the end of where you were. It doesn't switch down to the next line. So println switches to the next line. And then, so this is an interesting function right here. This allows us to automatically map between two ranges. So we have ADC max, so that's 0 to 4096. Here's our value. We're saying take this value, which is in this range from 0 to ADC max, and instead put it in a range from 0 to 180. So in other words, if we had a value that was 25% of the way from between 0 and 4095, then it would put it at 25% of the way from 0 to 180. So that would be what, 45. So we would put the number 45 in here, and now we'd print out servo value, and that would go to 45 degrees. And then again, the print line prints that out. And then the myServo.write, that writes that value to the servo, which is expecting a value between 0 and 180. So anyways, the thing to learn here is that you can attach this library, right? You can, once you have the library attached, you can create an object from that library, and it's good to set constants to these pin numbers, so that way if something changes in your program, you just change it up at the top. You don't have to find all the different numbers. If you look at like this line right here, which says servo pin, then it's obvious that, yeah, that's the pin that the control wire for the servo is plugged into. Okay, and then we also talked about how to do an analog read, how to use the ADD converter and get an analog read. It will put the voltage, which it reads somewhere between 0 and 3.3 volts. It puts that into a number between 0 and 4095. So now if you want that to be, linearly distributed in a range from 0 to 180, you can write your own equation, of course, to do that, or you can just use this map function. So I'll just point out again that you can always go to help and then reference tutorials, and so we just installed the library. So here's examples from libraries, and there's servo right there, and I did the knob example. So again, shows you how you would wire that up. So this one, this is for an Arduino, and the Arduino, the voltage used on in the board itself, the logic and the to run the board is 5 volts. With the ESP32, it's 3.3 volts. So you never want to, input more than 3.3 volts into the board. You can do it, and it works for a little while, but then eventually you damage the board. So like the way this one, here's the potentiometer, and you can see this is hooked up to, it's grounded here, and then it's hooked up to actually 5 volts. And then the middle one, which is the sweeper voltage, that's going into the analog input right here. So you wouldn't want to do that on the ESP32. You'd want to hook up the power to the servo over to the 3.3 volts. Okay, so because you want to put in a voltage between 0 and 3.3 into this analog to digital converter. And then your program will take that and convert it into a number that you want it to send to the PWM, which you want the servo to turn somewhere between 0 and 180 degrees. When you write to the servo, you give it a number, in the servo dot right of between 0 and 180, and then that converts it into a PWM signal. You can see there's a PWM symbol right there. So that sends a PWM signal of the right duty cycle into the servo. And the servo itself, see this is an output, so the servo itself could actually, that could be run, or if it was a motor, it could be run like at 12 volts. That's not being inputted back into the board. So this is an output, but right here, this is an input. Okay, so at any rate, here's a schematic for that. There's the servo, here's the potentiometer, and the code. Right, so and there's that mapping function. We're actually going from 0 to 4095 or 4096. Either one's fine. Okay, so the last thing we'll look at is you have this skeleton program, the ADC program, and you can see this is set up so that ADC pin is 26, right? Pin mode, that's set as an input, right? So we're going to use that as an analog. That has to be one of the pins that can be used as an A to D converter. This just sets up the baud rate to the screen, and so what we do here is use the analog read to read that pin, put that value in here. Says edit this line, right? So you want to say ADC voltage. Well, you can figure out how to convert that. That's easy enough to do, or you can just use the map function, either way. And then you're going to print the ADC value, and then just prints a tab, and then do the serial print on the ADC voltage, and then you have a new line here, delay 250 milliseconds. Right, so what you'll see on your computer screen then is the analog to digital value, 0 to 4095, and then the actual voltage that represents. So then from here you can just add the things you need to do for your homework assignment. So anyways, hope that helps.